Yeah, thank you for that introduction. So again, my name is Justin Calhoun. I'm going to be presenting today about some work that we've been doing to try to just determine a residual length of control for some of the commonly soil applied herbicides in peanut. So I want to begin my presentation today just talking about a danger that we of weed scientists have been dealing with over the past decade, and that's the danger of herbicide resistance. And it's specifically about how underestimated it may be in peanut production. If we look at the International Survey of Herbicide Resistant Weeds, we see that there are only 3 cases of resistance reported in peanut, and those all consist of ALS resistance. However, knowing the areas that we grow peanut in and what fields we rotate them in with some other crop production systems, we know that more cases actually exist than what are being documented through this survey. Specifically, if we look at something like Palmer amaranth, we know that there are PPO, ALS, and glyphosate resistant cases of those in other crop production systems. Now, the glyphosate resistance wouldn't be as big of importance in peanut, as glyphosate is only labeled as pre-plant burn down. But PPO and ALS herbicides we rely heavily on for in-season weed control, and having resistance to those chemistries are extremely dangerous. Another one, barnyard grass, we know is also persistent in peanut growing areas, and it has been documented to have ALS resistant cases in those areas. And neither of those are recognized by the International Survey of Herbicide Resistant Weeds. So not only do over-reliance on foliar chemistries result into resistance cases like these mentioned, but they also result in a reduction in the use of soil-applied chemistries. And we know that soil-applied chemistries are an essential tool and extremely important in increasing the number of mechanisms of actions that are used in season in crop production systems, and they also reduce the resistance development potential by doing that. So in my mind, as a young weed scientist, I think this calls for a need for change. With reduced options that we have for foliar control due to resistance development, why not focus on controlling these problematic weeds before they emerge? Why not push for a soil-applied chemistry to become the most used active ingredient in peanut production versus maybe some of these foliar-applied chemistries where we see more prevalent herbicide resistance development? So this led us to develop some studies with the objective of just determining the length of residual control produced by some of our commonly utilized soil-applied herbicides in peanut. We did this with the hypothesis that greater than 21 days of residual control could be achieved by some of these commonly used residual herbicides. So to do this, we conducted studies in 4 locations in 2020 and 2021 at the RFR Full Plant Science Research Center here at Mississippi State, at the W.B. Andrews Research Farm, again at Mississippi State, the Coastal Plain Branch Experiment Station in Newton, Mississippi, and then an on-farm research site there at Tillar, Arkansas. And to stay standard across all locations, we used a peanut variety of 06G to represent in-crop weed control exhibited by these pre-emergent herbicides. Now, we set these studies up in a randomized complete block design with 4 replications, and our treatments comprised of commonly used pre-emergent herbicides that are labeled for use in peanut. So those treatments consisted of 10 different herbicides that you see listed here in this table, and then also a few treatments of just secondary curiosity objectives. For example, treatment 6 and 7, you'll see both were applied with pendimethalin. We just wanted to compare the satellite hydrocap formulation to the Prowl H2O formulation. Also, we included there with treatment 12, a tank mix combination of 2 different pre-emerge products mixed together to see if 2 residual herbicides provided more weed control or weed emergent suppression compared to those herbicides alone. Now, it is worth noting that each treatment received an application of paraquat and crop oil at the time of planting to terminate any existing weed populations that were already in the field. And that's going to be important as we get into some of our results later in this presentation. So in terms of materials and methods, we applied these treatments to 4-row experimental units with our row width being 96.5 centimeters, and our plot length was 9.1 meters. We applied these treatments using a tractor mounted sprayer that you see here pictured on the right, calibrated to deliver 140 liters per hectare using XR110015 nozzles. So in terms of data collection and analysis, we did visual weed emergence evaluations taken weekly after each pre-emergent application, and visual ratings were conducted all the way out until 50% emergence for each treatment occurred. And at this point, we would determine that beyond 50%, that herbicide was not significantly contributing to any weed emergence response. Therefore, it was completely lost in terms of control. And this data was subjected to ANOVA, and means were separated using Fisher's protected LSD with an alpha of 0.05. And then we also wanted to try to include time as a factor, since our objective was to determine a residual length of control. And so we subjected this data as well to nonparametric regression, where we modeled weed emergence over time for each of our herbicide treatments. And I'll talk more about that a little bit later. So first, we're going to get into our ANOVA results. And here we're looking at broadleaf signal grass emergence at 14 days after our pre-emergent application. First, let me set this graph up for you. On the x-axis, we have all of our herbicide treatments. And on the y-axis, we have our response of interest. Again, in this case, it is broadleaf signal grass emergence. What we see at 14 days after application is that none of our soil-applied herbicides resulted in any difference in broadleaf signal grass emergence, and all resulted in less emergence compared to our non-treated check. However, when we move into 28 days after application, we begin to see some of these soil-applied products losing control or allowing broadleaf signal grass to emerge. Specifically, when we look at products like ethafluralin, diclozolam, and trifluralin, we see that they have exhibited emergence of around 50 to 60% for broadleaf signal grass. And then when we look at products like esmetolachlor, flumioxazin, dimethenamide, and our tank mix combination of pendimethalin and flumioxazin, we see broadleaf signal grass emergence lower than some of our other soil applied chemistries, down there around that 10 to 20% emergence rate. So if we summarize this ANOVA data, we see, again, at 14 days, all of our soil-applied herbicides resulted in similar weed emergence suppression. By 28 days, we began to lose control in some of those products. However, with esmetolachlor, flumioxazin, dimethenamide, and pendimethalin plus flumioxazin, we maintained some acceptable levels of suppression, which were lower than some of our other products that we tested. However, the one drawback to this is that using ANOVA and multiple comparison only allows for comparisons within individual evaluation timings, and it doesn't consider time. And so we were trying to come up with a way that we could factor time into this to where we could accurately determine a residual length of control. And so to do this, we utilized nonparametric regression. Now, if you're not familiar with nonparametric regression, it's really quite simple. We first just took our herbicide data sets and subsetted it by individual herbicides. And so what nonparametric regression does then is models our response, in this case, percent broadleaf signal grass emergence over time for individual herbicide treatments. And so to do that, it fits a unique curve to each individual herbicide data set, which is represented by this black line going through this graph. It then derives a 95% confidence interval around that unique curve. And so what that allows us as analysts to do is to go in and set a threshold, and we can find where that confidence interval then intercedes that threshold. So for example, we have here a 20% emergence threshold. And for this example herbicide, greater than 20% emergence, we could say with 95% confidence, occurs somewhere between 19 and 24 days after application. So if we get into some of our results, again, we're going to look at broadleaf signal grass emergence for these individual herbicides, and we're going to use that 20% threshold. Beyond 20%, we would recommend having a post-application to go ahead and control those weeds that have emerged to mitigate any yield effect that we may see from that weed presence. And so if we look at here at our results, on the left-hand column, we have our herbicide treatment. In the center two columns, we have our minimum and maximum values represented by our confidence interval where that intercedes that 20% threshold for our individual herbicides. And what I want to draw your attention to is that non-treated check treatment. Now, remember, I mentioned that we applied paraquat and crop oil burn down at planting to eliminate any existing weed populations. And what we see is it took about 7 to 9 days for our weed population to then reestablish after that application. Now, I'm not trying to say that paraquat has a residual activity of 7 to 9 days. We know that it has no residual activity as it is tightly bound to the soil. But what this does indicate is that due to environmental conditions, whether it be moisture or temperature, it did take about 7 to 9 days for a new population of weeds to germinate and emerge following that burn down application. Therefore, any residual length of control that we may have had from products applied at the same time may be in reality about 7 to 9 days overestimated. So to standardize our data, we then remove that 7 to 9 day delay in emergence from our length of control for our products. And we have that data represented in the two far right-hand columns. And what I'd like to draw your attention to are those products that we determined in ANOVA resulted in reduced stands of broadleaf sentinel grass at 28 days after application. And those were esmetolachlor, flumioxazin, dimethamid P, and pendimethalin plus flumioxazin. And what we see for these is that our threshold where we maintain 20% emergence or less extends out to around 21 days for these products. So in summary, the majority of our herbicides, according to our regression analysis, resulted in suppression duration of about 10 to 18 days beyond our non-treated check. Several of these herbicides, though, extended out to 21 days beyond the non-treated check. Again, those included esmetolachlor, flumioxazin, dimethamid, and flumioxazin plus pendimethalin. And this analysis estimates that greater than 20% emergence for these particular products occurs somewhere between 21 and 28 days. So in conclusion, some herbicides are capable of producing residual durations greater than 21 days in crop. And so we fail to reject our hypothesis. With this, we would conclude that herbicides with longer residual durations could, first of all, aid in management of herbicide resistance development and reduce the cost of post-applications, proving both of these points by reducing the amount of foliar applications that may be necessary if we utilize some of these products that do exhibit longer durations of control. With that, I would like to thank my committee members, my fellow graduate students and undergraduate students for their help in this research, as well as the MAPHIS SRI Grant Funding Research Initiative for funding this research. With that, I'll gladly take any questions you might have.
Thank you very much for that presentation. And we have several minutes for questions if there are any out there. You know, it's been my experience that weed scientists are generally a shy bunch, Justin, and I'm afraid to ask any questions. So any questions from the audience? I have a question, and this is as far as longer residuals, that would have nothing to do with length of time in the environment. A longer residual would not affect chances for labeling or anything with the EPA, would it? Would there be any questions as far as the product longer residuals as far as activity? I assume they're two different things that could be looked at.
Yeah, an excellent question. Yeah, as far as labeling with the EPA, really when it comes to soil applied herbicides, the biggest concern is how mobile and how highly leached is it. And so, you know, in reality, if we're really increasing absorption and that herbicide is sticking around in that soil, then it must not be highly leached. So honestly, I would think it would be the inverse of there's enough herbicide maintained in the soil and it's not moving off to unintended sites like soil, water sources or anything like that. But no, we really don't consider length of residual control in terms of EPA labeling, just really environmental concerns.
Okay, great. Thank you, Justin.
Yeah, thank you.
Any further questions? Okay, thanks for that.